Okay, so we're gonna continue on with our next example, solving nonlinear systems. So in this example, we have another quadratic and we have another line, but notice that the line is not set up like it's ready for substitution, but that really doesn't matter because this one technically is, okay? However, I'm gonna go down the road that most students go down, and I can get the y by itself in the second equation by adding 2x. And I have y is equal to 2x minus 3. And now I can replace y with 2x minus 3. Or I could even replace y over here with x squared minus 2x plus 1. However, let me just go down this other path. So the other thing I could do is I could put this in here for y, in which case I would have x squared minus 2x plus 1 minus 2x equals -3. And then I could drop the parentheses because there's nothing to distribute and combine my like terms, and I'd have x squared minus 4x plus 1 equals -3. And then experience tells us that we have to move the -3 over to the side, and I get x squared minus 4x minus 4 actually lies plus 4 equals 0. Okay, which is the same thing that's going to happen over here. Okay, so if I go back to the way I was doing this in the PowerPoint, again, instinct should tell you, spidey sense should tell you, got to move this 2x and this -3 over to the other side because it's a polynomial. That's the only way you can solve a polynomial. Those cancel. Remember, I have to do it one side, I have to do it to the other. And look, I ended up with the exact same quadratic that I ended up with over here by going down this other path. And then we solve this by factoring. Choose life, factor. If you must, then do the quadratic formula, or yikes, solve by completing the square. But nobody ever really does that. Anyway, this factors out to x minus 2 minus x minus 2. If I put those both equal to 0 to the same equation, I get x is equal to 2. But remember, you're not done because you have to find the y coordinate, because when they're asking for you to solve the system, they're asking for the intersection point, and a point has an x and a y coordinate. So again, you have the power of choice. You could choose to plug it into the first equation or the second equation. Doesn't really matter. Okay, so I chose the second equation. Normally you would go with the unadulterated version, which means the original, because you want to make sure you didn't make any mistakes. But you know, I didn't make any mistakes, so I'm going to plug into this modified version where I solved for y and got y is equal to 2x minus 3. Anyway, we plug in everywhere we see an x, we replace it with 2, so there's only one spot, which is here. So 2 times 2 minus 3, follow the order of operations, and we get y is equal to 1. And don't forget to write the answer as a coordinate. So there's only one intersection point, so that must mean that the parabola and line are tangent. Okay, and I'm going to show that here graphically. If I were to graph the parabola and the line by hand or cheating and using a calculator, you could see that the intersection point is right here, and that's that same point, which is 2, 1.